Hello everyone, today we'll talk about the solution to the problem find longest special substring that occurs thrice, 1. Though this will also solve the same version just with a 2 at the end, because the second version, the only difference is that the constraints are more harsh, but our solution will pass both of them. So just know that this first problem will allow also for some slower solutions, but the solution is fast enough for both. Now, the essential observation, in my opinion, to solve this problem easily is that, and this is not a unique observation to this problem, it also happens in many different cases, and it's easy to miss it, especially if the problem is more involved, is that we are given the definition of a special string as being made up of only a single character, of course, repeated, but a single character. And that observation is that the categories of strings that we can get is just 26 different categories. One category per lowercase English letter. And perhaps if we focus on each category separately, the problem will become easier and we can do it 26 times and solve the problem. Because here we have to find the longest special substring, so the longest substring consisting of this only a single character repeated, that occurs at least thrice, and of course there can be overlaps between those appearances. But if we look at the single character, then this just tells us what is the longest substring consisting only of that character, which occurs at least thrice. And it's easy to see that it's easy to find that longest substring appearing so many times. That's because we can simply look at the occurrences. That's the solution that doesn't require much thinking. We can just look at all the occurrences of that letter. We can look at the longest substrings, contiguous substrings that contain only that letter. And if we get a contiguous substring of length L, then this will give us a single occurrence of length L, two occurrences of length n-1, L-1, right? Because the one that starts at the beginning and that one that starts 1 to the right, two occurrences of L-2 and so on. And so we can just calculate, even in the simplest case, and this is the solution that I'm going to show, we can just calculate all of those occurrences. So even if our substring has length 200, we can calculate as a single 200, we get twice 199, 3 times 198, and so on. It's easy to see that it's not necessary to go through all that, but it's possible to go through all that, and the solution's complexity is still the same, because it's still linear. And then we can go through every letter and see what length gives us the biggest special substring of that letter, and the maximum of all the letters of that value is the result. So first we have to calculate the blocks consisting of the same letter. So this is by the way, we'll be maintaining counts in a counter. We have it for every letter, so we have a default dict of counters. Now to calculate the length of blocks, we can simply just remember previous character, count of previous character. Whenever we see a character that's not equal to previous, we see that this is the end of a block. So we have to add 1 to the count of length of block, 2 to the count of length of block -1, and so on. So this is this for loop. And of course remember that now the new previous character is C, and count is 0. After every step we increase the count by 1, in order to not have to paste this block from 7 to 9 after 4. We can just chain our string in some character that's not a lowercase letter, to make sure that this runs also for the last block. And now this is the solution proper. Our result starts at -1, just as we're told. And now for every letter, MV is the maximum length of its occurrence as a substring. So we just get it, we set as default -1. And again, without much thinking, we can just go through all the values from MV downwards. So from MV +1 to 0, and the step is -1. And if it occurs more than 3 times, we update our result and we break, because this is the best for that letter. And the best through all the letters is the result for the final problem. So this is a very simple problem, as it turns out, and you get 2 problems for free by solving it. And this observation, which is really obvious, that there are only 26 letters, so only 26 classes of special substrings, is sometimes surprisingly useful.